Thank you for joining us today, and in this video we are going to look at an exponential function in addition with power rule, right? So we've talked about power rule already, and then what we want to do is we want to look at how we can differentiate exponential rule too. So what is the derivative of this? This is very simple. So since the top here is a linear function, all we just need to do is we drop the k and then we maintain the function again. That's all. So this is how it's going to be. But in more like how we differentiate an exponential function, I will show you. If I want to differentiate e to the power kx, this is differentiate what is on the top, which is kx, maintain the function kx, and then pick length of the base. Right. So when I do that, when I differentiate this, since k is constant and multiplying the x, I'll have k, and then when I differentiate x, I'll have 1. E to the power kx times ln of e to the power 1 is 1, and this will be k e to the power kx. So that's the idea. So here, the idea is that if I want to differentiate this, then I just need to drop what is on the top here down. Drop the k and maintain the function. So drop the k, maintain the function. This happens when the k is constant. So what you need to know is k here is constant. Yes. So that is what you need to also know from this function here. So very simple to go with. So now let's go through the process by differentiating the following functions, right? So what will be f prime? So f prime of x will be equal to, so 4 here is multiplying this. So since it's multiplying and it's constant, I'll just to maintain that one out. So my 10 is now differentiating 2x. So from what we just did, I just need to drop the 2. I pick the 2 and multiply it by this. So the 2 times 2x. Then when I differentiate a constant, I get 0. So this should be 8e2x. Very simple. Very simple. Let's look at gen prime. Gen prime of x will be equal to, now when you look at this function, I have e to the power minus. So what I need to do is I need to pick the coefficient of the x and use to multiply the whole function. So minus 9 e to the power minus 9x. Very simple, right? Then the power rule plus 6. So since 6 is multiplying x to the power 3, I just have 6. Then I differentiate x to the power 3, which will be 3x squared, right? So 3 minus 2, 3 minus 1 will be squared. So I'm going to have minus 9 e to the power minus 9x plus 18x squared. Very simple. Now I want to differentiate this. Remember when we started the idea of power rule, I was like, if you have something like 1 over x, this is the same as this, right? And we went ahead and said, okay, if I have 4 over x, this is the same as 4 times 1 over x, and this one can be written as 4 times minus 1. Or in other contexts, we say like if I have 5 over x, if I don't want to go through this process, then this will move up here, right? So it's going to be 5x, then I subtract minus 1. Good. So that is the idea. So if that's the case, then this can be written as minus 3, then times 1 divided by e to the power 4x, right? And based on that, we can write this one as minus 3 e to the power minus 4x, because this is moving up. So we need to subtract. We need to make this one negative. If this is negative, then this one will be positive. So now what we need to do is now we need to differentiate this using the idea of the exponential function that we just learned. So minus 3 is multiplying it, so it's a constant. So we bring it in front. Then what we need to do is pick the coefficient of x and use to multiply the whole function. So it will be minus 4 e to the power minus 4x. So this one will be 12 e to the power minus 4x. So very simple, very, very, very simple when you are dealing with this one. But one thing that you need to also learn is, let's assume that I have like gen of x is equal to this. Now you can see that this does not depend on x. There is no x in it. So this is a constant. So gen prime of x will be 0. So that's one thing that you need to also learn from here. Now let's differentiate f prime of x. When I differentiate t squared, I'm going to have 2t, right? Then minus, when I differentiate this, I'll pick, so as usual, I'll pick the one here used to multiply the whole function. So I'm going to have minus 3 e to the power minus 3t, then plus 0. When I differentiate a constant, I get 0. So I differentiate 8, I get 0. So this one will be 2t plus 3 e to the power minus 3t. So that will be that. Let's look at gen prime. Gen prime of x will be equal to 10. Then I want to differentiate 0.8x. So since it's a linear function, I'll just pick this one in front and then multiply it by this. So 0.8 e to the power 0.8 x. Then 0.8 times 10 will be 8 e to the power 0.8 x. Very simple. Very, very simple. So differentiating an exponential function is very, very simple. Let's look at the last question here, and then I think we are done. Now, find the equation of the tangent to the function here. So equation of the tangent, it depends. We have many formulas. Somebody can write it in the, like y minus y1 is equal to the slope x minus x1. You can also write it as y minus f of a is equal to f prime of a, then x minus a. Any of them, like any of the way you are going to write, is the same thing. But me, I'm going to use this one, the second one that I wrote. Now what you need to know is your a here is the x given, right? So this is equal to a. So if I'm using this one here, then my a is equal to -1. So I use this one. This one helps me to know all the things that I need. So when you write this one, sometimes you get confused because you won't even know your x1, your y1, getting confused with everything, right? So it's good to go with this one. So if my a is -1, then I can find for f of a, because a is 1. So I'm going to have y minus a is -1, which is equal to f prime of -1, then x minus -1. So when I simplify, I have y minus f of -1, f prime of -1, x plus 1. So all I need is I need f of -1 and I need f prime of -1. So I have f of x here. So f of x is equal to 8 this. So what will be f of -1? So it will be 8 e to the power -3 times -1. So I'm replacing, if I put this one in parentheses, I'm replacing the one in the parentheses by -1, which is the same thing here. So this, that. So this is going to give us 8 e to the power 3. So that's what I'm going to get. Now what I need is I need f prime of -1. But for me to get f prime of -1, I need f prime of x first. So that now when I get f prime of x, I can substitute the -1 inside. So this one, we know that f of x is equal to this. So we need to differentiate this. So differentiating this, 8 is constant. So I maintain it. Then I need to differentiate this. So differentiating e to the power -3x, as we said, pick the coefficient of the x and multiply by the whole function. So -3 e to the power -3x. And 3 times 8 is, I think, 24. So -24 e to the power -3x. Then I can make sure I put my x's in parentheses. so that now I need f prime of minus 1, which is here. So I'll change all the 1 in the parentheses to minus 1. So I'm going to have minus 24e minus 3 times minus 1, which will be minus 24e to the power 3. Good. So I have everything set up. So this one will be from here. This one will be y minus. What is f of minus 1? We had this. So we are going to have minus 8e to the power 3 is equal to, what is f prime of minus 1, which is also this. So we are going to have minus 24e to the power 3, then x plus 1. So we are going to have, if I want to expand y is equal to, then I'll multiply this by this. So I'm going to have minus 24x e to the power 3. Then I multiply this by this. I'm going to have minus 24 e to the power 3. Then I'm going to move this minus 8 to the power 3 to the right side, which will become positive. So I'm going to have plus 8 e to the power 3. So when I simplify, minus 24 e x e to the power 3 minus, now since this and this are the same, we can add the exponent. So 24 minus this one is going to give us minus 16e to the power 3. Yeah, and then I can decide to even pull out this and this out. You can just leave your results here or even here if you want to, but I can even also pull out the e to the power 3, and then this is what I'm going to get. So this is the equation of the tangent line. See you in the next video.